All right, hello everybody. So today we're going to get into our last little chunk of notes over sig figs and scientific notation. Hopefully the scientific notation should be a review from math class, but we will review how to go from standard form to scientific notation and then backwards as well. We're also going to talk about how to multiply and divide sig figs. Okay, so multiplying and dividing sig figs. So yesterday we talked about adding and subtracting, where we worry about the sig figs behind the decimal. Well, the easy part, or the nice part about multiplying and dividing, we worry about all of the sig figs here. So we do not have to worry about, is it behind, is it only certain ones? We worry about all of them. So just like what we were doing before, telling us how many are in the number is exactly what we're going to be doing now. So just like yesterday when we were doing our our adding and subtracting, the first thing we do is we just solve it. Solve it as normal. So what we're going to do is we're going to take 3.05 divided by 8.47. Hit equals, and you're going to get a number of 0.3600944451. Again, I suggest write it all out just to make your life a little easier so you don't have to worry about how many sig figs you need to go to and if you're going to have enough digits. You just treat it as normal. So next thing we do is we figure out how many sig figs in total are in each number. So we're looking here. 3 is a sig fig, the 0 is a sig fig because it's sandwiched between two numbers, and 5 is a sig fig. So that means we would have 3 sig figs here. Then we look at 8.47. 8's a sig fig, 4 is a sig fig, 7's a sig fig, so it has 3. Just like yesterday, we always go to the least amount. Well, these are the same, so they're going to be 3 will be our final answer of sig figs. So again, we look, the leading 0 here is not significant, so we start with the 3. 1, 2, 3. Look behind, it's a 0. We are going to stay the same. So our final answer would be 0.360, and that would be grams per milliliter. And that would be our final answer. So again, solve like you normally would. Then you will figure out how many sig figs you need to go to the least amount, and then go from there. All right, let's do a couple more examples. So we have 2.4 grams per milliliter divided by 15.83 milliliters. So what we'll do, we'll multiply the two together. You should get an answer of 37.992. Okay, so we go back to our numbers. We have to figure out how many sig figs are in each number. So 2 is a sig fig, 4 is a sig fig, so we have 2 here. 1 is, 5 is, 8 is, 3 is, so that would be 4. Again, we always go to our least amount, so we're going to go to 2. So again, we start at the beginning because we're worried about all of the sig figs. We go 1, 2. We look behind, it's a 9. Round up or stay the same? Well, we're going to round up. So it would be 38, and that would be grams as our final answer. Then we try the next one, 1.34 micrometers times 0.7488 micrometers. So when you multiply those two numbers together, you should get an answer of 1.003392. Now we need to look and figure out how many sig figs are in each one. So we have 1, 3, 4, so there's 3 sig figs here. We know this 0 is not significant, so we have 1, 2, 3, 4. So we have 4 sig figs here. So we always go to our least amount, which would be 3. So again, we go back to our number, go to all the way to the beginning. 1, 2, 3. We look behind. It's a 3. So it's going to stay the same. So we have an answer of 1.00, and that would be micrometers. Okay, last one here, 10.8 times 102. When you multiply those two numbers together, you should get 1,101.6. Again, we need to look at our numbers and figure out how many sig figs to go to. So we have 1's a sig fig, the 0 is a sig fig because it's sandwiched between two numbers, and 8's a sig fig. So there are 3 here. 102, 1's a sig fig, the 0 is a sig fig because it's sandwiched between two numbers, and 2's a sig fig, so we have 3. They're both 3, meaning we're going to go to 3. So we go here, 1, 2, 3. Look behind, it's a 1. So we're going to stay the same. Now, our answer would be 110, but our number here is 1,101. Those two numbers are not even close to each other. So what we're going to do is we're going to add in a place holding 0 to try and get this number as close as possible to the original. Now, we talked about this yesterday. I cannot add a decimal because the minute I add a decimal here, it changes that to 4 sig figs, and I need to go to 3. So we leave it without a decimal. So we can still have our 3 sig figs without worrying about it. And our final unit would be centimeters. So again, our numbers need to match as much as we can, so we just add those place holding zeros. Okay, let's do a quick check. So what is the sum of 7.3 meters and 42.09 meters? Okay, well, the first thing we have to ask ourselves is, what are we doing here? Are we adding, subtracting, multiplying, or dividing? So we go back and we read through the problem again. It says sum. Well, sum in math means adding. So we're going to add 7.3 plus 42.09. So that means we should get an answer of 49.39. Now we have to remember, when we're adding and subtracting, we only worry about what's behind the decimal. So 7.3 has 1 sig fig. 42.09 has 2. We always go to the least amount, so we're going to go to 1. So we go 1 behind the decimal. Look behind, it's a 9. So we are going to round up. So we get 49.4 is our final answer, which would be C. All right, let's do another one. So solve this problem. 24.355 divided by 6.213. So we're just going to plug that into our calculator like normal. Divide the 2. You should get an answer of 3.92006438. And again, I recommend writing it all out just so that you have it. Okay, now that we're dividing, we need to worry about all of the sig figs. So I go back to my numbers in the problem. I start at the beginning. Again, there's a decimal present. Go to the beginning, hit your first number. Everything behind it becomes significant. So we have 1, 2, 3, 4, 5 sig figs here. Do the same thing. We have a decimal present. We go to the beginning. 1, 2, 3, 4. So we're going to go to 4 sig figs. We always go to our least amount. Start at the beginning. 1, 2, 3, 4. We look behind. It's a 0. So we are going to stay the same. 3.920. So that would be B. Okay, so that is how we multiply and divide by our sig figs, and also how we talk about adding and subtracting. Now we're going to get into scientific notation. We use scientific notation a lot in chemistry, purely because we have some really big numbers, and it's just easier to talk about them in scientific notation than it is writing numbers that have 30 digits to it. So scientific notation are numbers written in the form of m times 10 to the nth, where m is the number greater than or equal to 1, but less than 10, and n is a whole number. So m is referred to as the base unit, n is referred to as the exponent. So when writing in scientific notation, only use the sig figs are used. So when we are talking about scientific notation and what comes in front of the times 10, so the m, we always have to make sure it is in sig figs when we're trying to figure that out, just to make our lives a little bit easier. So here is an example. So determine the m by moving the decimal point in the original number to the left or right, so there is only one non-zero digit remaining to the left of the decimal point. Determine the n by counting the number of places the decimal was moved. If the decimal was moved to the left, the n value will be positive. If the decimal was moved to the right, the n value will be negative. I would star, highlight, whatever you got to do so you remember to go back over that. That's the most important part. So if we were solving these ones here, where we have 0.00012 millimeters, and I wanted to put that into scientific notation, what I would do is I would take my decimal here, and I would jump it until I had one number in front of the decimal. I also would look and see those are all leading zeros, so my 1 and 2 are my only sig figs. So it would be 1.2 times 10, and then I count how many times did I move it. 1, 2, 3, 4 times. Now, like it just said, if you move it to the right, like we just did, it's going to be a negative exponent. If you move it to the left, it'll be a positive exponent. So we moved it to the right, so it's going to be negative. I always say the smaller the number, it's going to be a negative exponent. If it is a larger number, it's going to be a positive exponent. So for example, if we did the next one, 93,000 kilograms. Well, if there's no decimal present, make your own. Put it all the way at the end. We are then going to move it so there's only one decimal, or one number in front of the decimal. So not there, not there. That's two numbers. Now we only have the 1. Okay, so like we saw before, there was no decimal point originally, so there's only 2 sig figs. So we have 9.3 times 10, and we moved it 1, 2, 3, 4 places to the left, and so it's going to stay a positive exponent. So let's go do a couple more examples. Okay, so we have 3,340 centimeters. So we are given a decimal. So we are going to start here, and we're going to jump until we only have one number in front of the decimal. So not here, right here. We place our decimal. All of those are significant, again, because there is a decimal. So we're going to write them all out. 3.340 times 10 to the 1, 2, 3. And again, we move to the left, so it's going to be positive 3. Okay, then we look at B. We have 0.006000 kilograms. Again, we have a decimal right here. We're going to move it so that our number is in front of the decimal. So not here, but it is right there. So from there, everything behind that 6 is significant. So we have 6.000 times 10 to the 1, 2, 3. And it would be a negative because we went to the right, and it is a small number. Okay, last one here. So we have 45,030, sorry. That number, or that decimal, or the comma is in the wrong place. But what we're going to do is we're going to start at the back. Again, there's no decimal here. We're going to move until we have one number in front of it. Not there, not there, not there, not there, but there is one there. We're going to write that all out because they are all significant figures. 4.3 5, 0, 3, 2, 4 times 10 to the 1, 2, 3, 4, 5. And again, we move to the left, so it means it'll be a positive integer or exponent. So that was going from what we called standard form to scientific notation. Now we're going to go the opposite way. I'm going to give you scientific notation, and we have to go backwards into standard form, also known as standard notation. So move the decimal place to the number of places indicated by the n value. So if the n is positive, move the decimal to the right to form a larger number. If the n is negative, move the decimal to the left to form a smaller number. Again, I would star, highlight, whatever you got to do to make sure you go back over that. This can be easily confused. So like it says, if it is a positive, so just like our first example here, you're going to move the decimal to the right to form a larger number. So what I'm going to do, I'm going to take my decimal here, and I'm going to jump 5 times to the right. 1, 2, 3, 4, 5. Every empty space gets a 0. That means my answer is 2, 3, 0, 0, 0, 0. Now, the other one, if the n is negative, you're going to move the decimal to the left. So we're going to go to the left this time. 1, 2, 3, 4, 5. Put your decimal there. Every empty space gets a 0. So that means my answer will be 0.00002, 3. There's supposed to be a times here. And that'll be our final answer. Again, you can always double check your answers. If I moved it back, 1, 2, 3, 4, 5. 2.3 times 10 to the negative 5th. They match. 1, 2, 3, 4, 5. 2.3 times 10 to the 5th. So you can always double check to make sure you're doing this correctly by going backwards. So let's do an example. Okay, so we have the 4.70 times 10 to the 7th. Again, it is positive, so we're going to move our decimal to the right. So let's go back to our red. We go 1, 2, 3, 4, 5, 6, 7. And we add in our place holding zeros. So let's rewrite this as 4, 7, 1, 2, 3, 4, 5, 6. Okay, so we have 3.2 times 10 to the negative 4th. So now we're going to change that into standard notation. So I start with my decimal. I'm going to go to the negative 4th, which means I go to the left 4 spots. 1, 2, 3, 4. Place holding zeros for all the empty spots. 0.00032. All right, next one. So we have 9.7 times 10 to the negative 1st. So what we're going to do, again, it's negative, which means we're going to move to the left. So I'm going to take my decimal, move it 1 place to the left, and I should get 0.97. And 5.1 times 10 to the 0th, that means it doesn't move. So your answer would be 5.1. All right, let's do a quick check. So the following is the correct scientific notation for the value of 0.000589. Again, we're going to move our decimal so there's only one number in front of the decimal place. So not there, not there, not there, right there. Again, we only write sig figs, so it would be 5.89 times 10 to the 1, 2, 3, 4, but I moved to the right, so that means it's a -4. So it would be A, would be our final answer. Okay, so your homework for tonight is the back side of the worksheet you got yesterday. The Sig Fig worksheet or coloring worksheet that is due Thursday will also be out. So if you want to get a jump start on that, you're more than welcome. You do not have to, but I suggest it so that you have some more time to get that colored and get that done, because you'll also have some work time tomorrow in class as well. Again, if you have any questions, please feel free, shoot me an email, come see me tomorrow morning, and I will be happy to help you. Have a great rest of your day. See you tomorrow.